3rd. We are continuing to look at simplifying radicals. So get out your notes and we'll go over these. On this first one, sometimes you have numbers that are already simplified under the radical. So let's just try this one and see where it takes us. So if you break down the number 210, that can be broken down as 2 times 105, okay? And then to break down 105, you know it ends in a 5, so you can break that down as 5 times 21. And then 21, that came from 3 times 7. Okay, if you'll notice here, all of those numbers, they don't have a pair. They're all singletons. They're all single Pringles. So when you simplify this, it's already simplified because you have a 2 inside, a 5 inside, a 3 inside, and a 7. So when you multiply that out, 2 times 5 times 3 times 7, you just get what you started with. Okay, so you got to watch out for these. Sometimes it's already simplified. It's already in simplest radical form and cannot be reduced any further. Example 1 says simplify 3 on the square root of 50. So we're going to break down the square root of 50. You have lots of options here, but something I see is it breaks down as 2 times 25. 25 is a perfect square. It's 5 times 5. So when you're looking for pairs, those are your prime numbers. And then your pairs here, you have a pair of 5. So when you have a pair, that means they come together as one unit and they come out. That one unit comes outside the radical. Whatever's left over stays on the inside. We call him the single Pringle. So on the outside, don't forget we have this 3. So let's bring it down. We have a 3. And then one of those 5s came out because it became one unit. And then on the inside, you just have the 2. 3 times 5 is 15. And that's 15 on the square root of 2. Sorry, that 2 looks like a Z. Okay. Okay, so when you are simplifying and you have variables with even exponents, technically, if it has an even exponent, it is a perfect square. So what you can do is simply divide that exponent by 2. Well, what's 2 divided by 2? That's 1. So the square root of x squared is just x. So technically x to the first power. Okay. The square root of x to the 6th power, sorry, not a 6. You divide that 6 by 2. 6 divided by 2 is 3. So the square root of x to the 6th is x to the 3rd, or x cubed. And then x to the 10th, if you divide that by 2, you get x to the 5th. Okay. So basically, if it's got an even exponent, it's nice. You just divide by 2 for the exponent. Okay, if it's not an even exponent, you have to make it into an even exponent. So what I mean is on these, they're odd. So what is the highest even number we can break this down as? So we have x to the 3rd. We can break that down as square root of x squared times the square root of x, right? That's how I break it down into an even number. So then you would just divide this 2 by 2. 2 divided by 2 is 1. Square root of x squared is just x. And because this is a 1, it doesn't have any pairs. It just stays under the radical. So your final answer there is x square root x. Whenever you have an odd number, you're always going to have 1 that's left under the radical. X to the 5th. I would break that down as x to the 4th, square root x to the 4th, times square root x. Square root of x to the 4th, divide the 4 by 2, and that is x squared. And then you still have square root x, right? X to the 11th, again, the highest even number I can break it down as would be x to the 10th times x, or x to the 1st. Divide that 10 by 2, you have x to the 5th on the square root of x. Okay, so let's put all this together. Square root of 40x to the 4th. Okay, break down 40. I see 4 times 10. Again, you might break it down as 2 times 20. Whatever you see, that's fine. You're going to end up getting the same prime numbers. 4 came from 2 times 2. 10 came from 2 times 5. So those are your prime numbers. And looks like we have a pair of 2's. And then we have a single 2 and a single 5. All right, so this x to the 4th, I'm going to go to this side here. Square root x to the 4th, well, it's an even number that exponent is, so just divide it by 2. Square root of x to the 4th is simply x squared. And then you have an empty house here, basically. There's nothing left on the inside. Put it all together. Let's do green. So on the outside, you had this 2 that came together. Remember, it's a pair. So they come together as one unit and they come out of the radical. So we have 2 on the outside. And then you had this x squared on the outside too. On the inside, you have the 2 times the 5. Okay, so this is just 2x squared square root 10. Nothing to it. Okay. All right, pause the video. You try this one on your own, see how you do, and we'll go over it. Okay, you should have paused the video. So what you can do here is break down the number 28. I see 2 times 14. And then 14 breaks down to 2 times 7. We have a pair of 2's here. Oh, you can't see that. Whoops. We have a pair of 2's and a 7. Okay. Let me go back. Okay. So when we have this, that 2 comes together and 1 comes outside the radical. Single Pringle is your 7. So y to the 5th, square root y to the 5th. Okay, break it down into some even numbers. We're going to break it down as square root y to the 4th times square root y. Okay. Square root of y to the 4th is just y squared. Square root y is just square root y. It didn't change. Okay. So putting that all together, let's highlight or circle some things. Let's do green. So on the outside, we're going to have a 2. We're going to have a y squared. On the inside, we're going to have a 7. And we're going to have square root y. Put it all together. On the outside, you have a 2. And you also have a y squared. On the inside, that was the teal color, we have the 7 and the y. Okay. Next example. Example 3. Before you start breaking down 36, 36 is a perfect square. Okay, so if you just had square root 36, that is just 6. Okay, so square root 36, that turns into a 6 on the outside, right? And then we have x, y to the 4th, z to the 7th. Okay, so square root of x is just going to stay square root of x. It has no buddies, it has no pairs. There's technically an exponent of a 1. So you have to have 2 to make a pair. It doesn't, so it stays square root of x. Square root of y to the 4th. Divide that 4 by 2, and you get y squared. Okay, and there is an empty house. Nothing on the inside. Z to the 7th. Okay, we're gonna break this down as z to the 6th times, square root of z to the 6th times square root of z. okay? Z to the 6th square root will just be Z cubed or Z to the 3rd. And then on the inside, you still have that Z. Okay. So circle what we have on the outside. We have a 6. We have a y squared. And we have a Z to the 3rd on the outside. On the inside, we have got the X, and then we have the Z. Put it all together. On the outside, you have a 6. You have, let's go in alphabetical order. You have a y squared. And then we have a Z cubed. And then on the inside, we circled that in green. So that is just X, Z. Okay, one more example, then we're done for the day. Example 4, sorry. So we have 6 on the outside already. We have to break down the number 12, and then we have to break down a squared, b to the 5th, c squared. All right, so break down 12. You can do 2 times 6, and then 6 breaks down to 2 times 3. Okay, so those are your prime numbers we broke it down into. And I see a pair of 2s. And then we have this single 3. Okay, so that means a 2 is going to come out. A squared, that one's nice. Square root of a squared is just a. And then you have nothing on the inside. It's an empty house. Square root of b to the 5th. Let's break that down as square root of b to the 4th times square root b. And that's going to be square root b to the 4th is just b squared. Remember, you take the exponent there, which is a 4 divided by 2. And then the square root b stays square root b. Okay. And then c squared, so square root c squared, that's easy. Square root of anything squared is itself. So the square root of c squared is just c. It's got an exponent of a 2. By that 2 by 2, you get 1. Okay. Nothing on the inside. So let's circle what's on the outside and what's on the inside. Put it all together. On the outside, let's do green. We have a 2. We have an a. We have a b squared. And we have a c. On the inside, you have this 3. You have this b. Okay? So put those together. I didn't mean to do that. Next page. Okay. So on the outside, ooh, I forgot about this 6. We have this 6. Don't forget about it, like Miss Richards. We have this 6. We have this 2. Okay. What else did I circle in green? We have an a, b squared, c. On the inside, we have just the 3 times the b. So let's put this all together. 6 times 2 is 12. A times b squared times c is just a b squared c. And then, and that's a b. I know that looks like a 6. On the inside is just 3b. Okay, and that is your final answer. Okay, so the homework is to do all 14 questions. They are not that difficult. Simple. It shouldn't take you that long to do the homework, right? If you have questions, please make sure you contact your instructor. Thank you.